There we go. Hello. Good to see so many of you here. My name is Graham Tackley. I used to, until earlier this year, I used to be Director of Architecture at The Guardian. And while I was there, one of the things I did was built an in-house real-time analytics system. We ran a small team that built that revolutionized the way Guardian journalists could look at and understand how people were interacting with their content. Earlier this year, I decided to leave The Guardian, and I'm co-founder of a startup called Collider.com. And what we're doing is moving beyond the first-party traditional analytics of page views and attention time, and trying to understand better the impact of media, both on media itself and on society as a whole. So we're doing a whole load of work around trying to understand the impact that journalism has on our lives and on other journalism. So there's loads of stuff that we're doing around that. When we came to form Collider, I decided to implement the back end of that in Kotlin. And I've really enjoyed doing that. So what I've got here is a presentation which I'm going to run you through in IntelliJ around 10 things that I love, that we love about using Kotlin. This isn't necessarily the 10 most amazing things that Kotlin could do. This isn't necessarily the most advanced and super things that there are about Kotlin. This is just the 10 things that actually came to the top of my head when I came to do this talk. So I've got a simple file here. There's nothing magic about this. I've got a whole load of imports and stuff, and I've suppressed some warnings, but that's it. There's no magic going on here. Before I start, I want to do a very quick poll. So if you put your hands up and hold your hands up so I can count you. I'll approximate the count. So how many people here are using Kotlin in production right now? So that's about 15%, I'd say. How many people here have played with Kotlin at some point? 70%, you reckon? Yeah, that'll do. How many people here would rate yourself as primarily a Java developer? That looks like about 80. Yeah, it's a bit of a tricky question, this one. Okay, and how many people here would rate yourself as primarily using some other JVM language, whether that be Groovy, Scala? Okay, that's about 5%. Okay. So I made some assumptions when I came to do this talk as to what your level of experience is. So I've encoded that down here in a test. So this is just a plain JUnit test, and I'm using assert J. I haven't got any magic Kotlin wrappers. This is just using those Java libraries straight off. So let's press Control-Shift F10 and have a look at what this test says. This screen is bigger than I expected. I was worried that this whole test wouldn't fit on the screen. So I'm pleased with that. Hey, look at that. I guessed all of it right. So apparently, less than 50% of you use Kotlin in production. More than 25% of you have tried Kotlin, and et cetera, et cetera, et cetera. You can see the test. So apparently I've guessed the audience right. So if this doesn't work and you get nothing out of this talk, that's entirely down to me, and I apologize for that. Okay, let's move on. So number one thing I love is sensible type inference. Okay, so we've got some really simple code down here. Can you see it if I don't scroll it all the way up to the top of the screen, or do I need to scroll it up? Okay, let's scroll it up. No, not with that button. Okay, so I say val name equals John Smith. Val introduces a variable, and we can see it's inferred that to be a string. If I call split on that, it infers that that's a list of string. I don't know why I put that one in. I equals 7. That's an int. And that's not just an object variable. It is properly typed. So if I try and get my name, which is a string, and divide it by 2, I get a compile error there, and it's grumbling in a slightly odd compile error that actually can't find a divide operator for a string. And it works with methods as well. So if I call last name, it takes, so here I've created a function called last name. It takes a name as a parameter, which is a string, and it splits it. And that last operator there is a Kotlin list operator that gives me the last element of the list. So it correctly infers but last name takes a string and returns a string because it knows that that array of string, that list of strings, and I've got the last one's a string. So let's say, so much, so good. By the way, it's going to get a bit more interesting than this, so I apologize. I had to start somewhere. Number one was the hardest one to come up with, in fact. When I originally was thinking about doing this talk, what I was actually going to do was just take you through our code base that we've got live. And I started trying to work out which bits of the code base I could show that wouldn't involve me to have half an hour's explanation of what this code was doing before I could show you one line of code. What I've done instead, apart from the first few, all the other points, I've actually taken bits of code from our code base, tried to kind of get rid of the gunk around it, but they're based on real examples that we're really using in our code. Okay, so here's a really simple example. So if we take that Java class there, we can say it says, hello Java. It's got a member variable called name, and that's a string. In the constructor, we have to say that name is a string again. Then we've got a method called say hello, and we can have to say that returns a string. And then we've got a getter down the bottom that returns the name. And once again, we have to say that name is a string. Okay, I get bored of having to tell the compiler, whatever that is, 4 times that this thing that I've got is a string. The Kotlin equivalent down the bottom is quite simple. If we go hello Kotlin class, we've got a constructor, so the constructor is just that line there, which takes a name as a string. That val there says, actually, you know what, please create a member variable for this and assign it in the constructor, because people like to do that quite a bit. And then function hello, I've inferred the type, and I'm using string interpolation there. So how many times I have to say name is a string there? Exactly once. Okay, so that's number one, type inference. The amount of boilerplate that removes from your code is just is brilliant, I think. Okay, number 2, data classes. Okay, what does a data class do? Okay, so here's some example data classes. So like classes, except I've got the word data in the front. Over here, I've got one that represents a publisher. That's got an ID and a name, which are both strings. It's got a list of domains that publisher publishes on, and it's got a summary stats thing, that's got a question mark on it, so it's pretty optional. So that means it's optional. It can be null. All the other ones are non-nullable, but we'll come back to that later on. And now I've got a class summary stats, which has got just 3 members in it. What actually gets generated as a result of that summary stats class, so I ran the class file that generated through Java P, and you can see what it's actually generated is a real bean, right? It's generated getter methods for each of those variables. It's generated a constructor with 3 parameters. It's generated 3 component methods, which I'm not going to talk about today, but that's to do with if you do object deconstruction, which if you're a JavaScript developer, you know all about that. It gives me a copy method. I'm going to come back to that one. It gives me that weird copy default thing, which I've got no idea what that does, but I think it's something to do with default values for the copy. It generates me a toString. It generates me a hash code. It generates me an equals. Now, that's all the stuff that what I used to do in Java was create the class, create the 3 member variables, and hit the button that says generate me that big pile of gunk that does that. And it always generates me that hash code method, which has prime numbers involved in it. And I've never quite understood why, but I've always just accepted that if that's what IntelliJ does, that must be the right thing to do. But I didn't need to do that, because actually all of that happened just by me putting the word data in the front of that class. And why is that really important? Because when I'm the thing that I obsess around is code readability. Now, that's partly because my memory is utterly appalling. So I can't remember the code I wrote yesterday, and especially, obviously, I can't remember code that other people wrote yesterday. And being able to look at the code and understand what that code is doing is important. And when you've got lots of auto-generated code that you've built in there, you have to look at that code to understand whether everything changed. Now, has somebody changed that prime number to something that wasn't prime, and what does that mean? And all this kind of stuff. So when you've got auto-generated code that's actually put into your source code, just because it's generated, it's still a pain, because you still have to read it to understand what that class is doing. So let's have a look at what we can do with a case class. With a data class. So we've got up there, I could construct it. So the thing that took me ages to get used to on Kotlin, first of all, was the fact you don't have a new operator. You just call the constructor. And the number of times I'd put new in there and wonder what the compiler error was all about. I'm thinking, yeah, anyway, you don't put new. So that's creating a new instance of summary stats. I'm using named parameters. So I could have just done summary stats 17 for 23,000, but I use named parameters, so it's a bit easier to understand. And then you can see my test. So I'm asserting that the toString method looks like that. So it's a pretty decent toString. If I create another object with the same values, I can down here assert that that is equal. And you can see, well, we'll run the test, and it does equal. And then I can use the copy method, which creates me a new instance of the class, just changing some of the variables, some of the values inside it. So that's going to create one with an article count of 18, but topic count and social interactions both the same. So if we run that, the test pass. Great. I had a great idea that I'd have all these tests running, and then when I actually realized what happens when I come to do this talk is that I run the test and it goes green, and it's like, okay, yeah. Let's make it fail, shall we? So let's say that is equal to. Run again. And yeah, there you go. You can see, actually, they're not equal because the article count is different. Okay, so that's number 2, data classes. Number 3, the thing I love, is Java library integration. So I'm going to come back to this one, but looking at the way in which you can use Java libraries really well from within Kotlin. So what do I want to do with that data class? Well, actually, one of the things I'm doing is implementing an API, and I want to return JSON. So let's use Jackson to do that. So here, I've just created an object mapper, and I've called write value a string, and it generates the JSON from that. Why? Because that data class is just a bean, right? All the stuff that the Java libraries expect to be true about a bean just work. It's got all the standard getters, and it could have setters if I chose to do so, and it just works. So there's no Kotlin magic going on there. There's no wrappers. I haven't put anything special in there. That's just straight Jackson, and it works with data classes. Number 4. Okay, so you probably know this one. Okay, so null checks, but null checks in a less painful way. So let's take this method here to calculate stats for an article. So I've said this function takes a URL as a string, and it returns a set of summary stats. And if I try and return null from that method, actually I get a compile error. So you can see there, actually I'm not allowed to return that because I haven't said that summary stats is nullable. Okay, if I did want to do so, I'd have to put a question mark on the end of that to make that work. Okay, and when I call it, I get a very similar thing. That URL is not nullable. So if I call it with null, I get a very similar error message. Okay, and in actual fact, if I understand things correctly from what I see, the errors I get when I pass some of these functions to Java code is actually written in the code to do the null check as the first line of that function for me. So even if I go outside Kotlin world, it's still doing null checks for me. I think that if I've got that wrong, then that's not true. I'm pretty sure that I saw that happening. And so here's an example. I've got a method here which dumps those stats out to the console. This time takes an optional summary stats. So if I try and print that, I get a tiny little red underline there which says only safe or non-null asserted calls are allowed on that nullable type. So I get a compile error if I try and reference that nullable thing. And so what I do here is I check to see whether it's null or not, and then I can reference it. And you can see that's in bright green, which says it's done a smart cast to the non-nullable version because I've already checked inside that block that it's not null. So it's null checks, but without the pain, without some of the pain of null checks. And the only bit that doesn't quite work as beautifully as all that about that is when you're calling Java libraries, which we'll see in a little moment. Because Java libraries generally don't document or don't do explain in a machine-readable way whether they return nulls or not, you kind of get a hint, but it doesn't enforce that it might be null initially. I believe that Kotlin originally did do that anything from a Java library that didn't say it wasn't nullable, it did enforce it, but it was such a pain to actually write code for that it got removed. But we'll see some examples of that in a minute. Number 5, the collections library. Okay, so here I've got a simple test. I create a list of numbers, 1, 2, 3, 4, and 5. So that list there, if I look at the type of that, that's a list of ints, that's kind of as you'd expect. And I can square that list by calling the map operator on it, and that I'm passing a lambda to that map operator, which just squares that number, times I times I. And then I'm using assert j again, and asserting that that squared contains exactly those numbers. And what I haven't done in any of that code is I haven't got anything magic to teach assert j about Kotlin. I haven't done anything else around there. That Kotlin list is a Java list. It's a Java util list. It kind of, as I pass it to assert j, so if we look at what method call we're calling here, if we look at that assert j, actually this is almost completely incomprehensible, but it's an abstract list assert which is expecting a Java util list, right? So this is one of the really exciting things for me about using Kotlin's collections, in that they are completely transportable and transferable to Java code, to Java libraries and Java code. Okay, let's look at a more real-world example now. So here I'm going to do a search using Elasticsearch, and I'm using the Elasticsearch Java libraries to do that. What I want to return is this data class, which I'm going to serialize to JSON and return back as part of my API. In fact, I'm not going to serialize it to JSON. I'm going to give it to Spring, and Spring will serialize it to JSON for me. So I call Elasticsearch client, call it prepare search, add a highlighter field, set a query here. This is all just standard Elasticsearch stuff with a simple query string query and filtering on some topics. And then I call get. Okay, so far so good. That's pretty well what you'd have written in Java. And get gives me back a search response. Now you notice that's a search response exclamation mark. Okay, so what that's telling me is that this came back from a Java library, and actually Kotlin doesn't really have a clue whether it's nullable or not. Now, so it's kind of a warning to me to go and look up in the docs and see whether that's nullable. Now, I happen to know that this function doesn't return a null, so I don't do a null check here. And then I call .hit, .map not null. So when I'm calling .hits here, that's actually calling the getHits method on the Elasticsearch search hits response. Okay, so one of the nice things, which should have been one of my numbered points, I think, is that Kotlin gives, for where you've got getters and setters, it will create property equivalents that you can call instead. Which again is just around removing the gunk from your code. Okay, so I'm taking each of those hits and I'm doing map not null. So map not null is like map, but if that lambda returns nulls, then just throw away the result and don't include it in the resulting list. And I call highlight fields. Highlight fields is actually returning a Java util map. But then I call get headline. I use the square bracket syntax to call headline. And because it's a get on a map, that might return null. So I'm using this safe operator. So that's saying, actually, if this thing is null, then just return null. Otherwise, call get fragments on it. And in fact, I have to call that, because if I don't put that in, I get the same error message we had earlier, which is that only safe calls are allowed on a nullable thing, because it knows that the map get is not nullable. Then I'm calling fragments. Again, that's calling get fragments on the Elasticsearch library. And then, actually, if all of that returns null, because Elasticsearch decided not to give me back any highlight fields, then I actually just want to return null and ignore the result. Otherwise, I'm going to combine that string, get the string value of the fragment, and do a join of those strings together, and then finally return a search result. So that ends up returning a list of search results up the top. Now I'm going to come back to this example, because that isn't actually the code I'd write, but I'm going to introduce how I'd write that differently in a little bit. You know, it's there that the highlight is also shown up in that nasty bright green. Because I've done a null check on highlight, it knows that that's not nullable, so it's OK to call dot on it. There. Does that make sense? Good. You're very quiet. Okay, number 6, higher order functions with SAM support. I love talking about higher order functions because it's one of those things that sounds really clever and really fancy and everything else. And to be honest, I hate that name because it makes it sound a lot cleverer than it is. And it's just like, actually, you can pass functions around like you can pass objects around. It's really simple. And what I could do in Kotlin, oh, right, we're doing this example. Okay. What we can do in Kotlin, I was about to say, I had a short example here, but I've got quite a long example here. So let's talk about this example. So one of the things that I need to do is have a look at publishers' sites, look at the content that they're publishing, the URLs I'm finding from a publisher, and try and figure out whether that thing's an article or not. One of the consistent things around publishers is that the markup is generally incredibly variable, and sometimes it's very difficult to find out just by looking at the article itself, but their CMSs are pretty consistent about the way they form URLs. So one of the things I do is have lots of rules to try and look at a URL and have give myself a head start of understanding whether that thing might be an article or not. So I've created an interface which has a function which takes is article. That's a OK HTTP URL that's being passed in. It has to return true or false. Does this look like an article? One of the most common ways of doing that is looking at the last section of the article, the last path segment or last slug of the article, and try and figure out whether that looks like it was something that was generated by a CMS. And actually, there's a whole load of different patterns I want to apply. So what I said, I create an implementation of this interface that takes a function that looks just at the last slug and works out whether that might be an article or not. And the implementation of that is it calls URL.path segments, last or null. So path segments is on OK HTTP, returns a Java util list string. Called last or null, which is a Kotlin function on lists that finds the last element that matches the lambda there, or null if it doesn't find one, to find the last non-blank segment. If I find it, then the answer is, if I don't find a segment at the end, then no, this doesn't match. Otherwise, I call that function with the slug. And then here's a function that creates an implementation of that class. So we call last slug, and I pass it the lambda to say, actually, that regex to look for 6 digits at the end of the string is in that. That's kind of a bit of sugary syntax there. So what that actually ends up being is it.contains regex. But everywhere you do contains, you can do in instead. So that string to Boolean is just a higher order function, allowing me to pass a function around. So that's really useful. Nowadays I'm spending about half my time writing JavaScript or TypeScript, and I've kind of got used to the fact that that's just what you do all the time. That's great. Okay, let's look at another example. So inside our system, there's an event processing system. Here's a naive implementation of it. So I've got an event, which has got a string and a type, and it's got a whole load of other stuff in it as well. And I've got a service class, which is an event, which wants to send that event to other things in the system that are interested in it. And so I create an executor. So that's just a standard Java util concurrent executor. And I call submit. Now submit, so if you're using Java 8, this is what Java 8 does too. So I call submit, takes a runnable, which is an interface with a single abstract method. So I can just call that here by passing a lambda that takes no parameters and returns nothing. So that's good, I like that. Number 7, extension methods. Okay, so this extension methods are just a way of creating methods on other classes that you don't control. So at the top there, what I've done is defined on string a method called HTML entity decode, which actually calls string escape utils from Apache Commons or one of those, I think. And then you can see in the test that actually on a string, that method is now just available to me. I love this. Obviously, it could be open to misuse. It's not monkey patching, right? It's not actually fiddling around with the string object and globally across my entire system. I've got that method there. So that's a scope method. It's resolved at compile time. If I don't import it, it doesn't exist. But to all intents and purposes, it looks like I've got that method on string. So if I was writing this code here, then you can see actually HTML entity code shows up in the auto-completion, and it all just works. So that's good, and and to me, I don't like the mismatch of the fact that actually some methods I can call directly on the thing, and sometimes I have to do things like string escape utils and call some global function that I have to pass this thing into. This allows me to escape that on things that I don't control. I found it useful for things like on Elasticsearch, where sometimes like parsing the aggregations that come back from Elasticsearch are a bit of a pain. It's quite useful to be able to inject some stuff onto Elasticsearch to give me methods that make that a bit easier. But the great thing that I really love about extension methods is I can define them on the nullable version of the type as well. Okay, so this one here I've said this is defined on string, but it's also defined on nullable strings. On strings that are null. And so you can see there, now this method, I actually created this because I was using Spring again and passing query parameters to me. And if you don't pass the query parameter, Spring decides to give you null. If you pass a query parameter but it's an empty string, which many libraries actually choose to do for you, then you get an empty string. And it's I don't care, right? If somebody's passed me an empty string, I can't read that. I think that says 10 minutes. Right, okay. That's good. Yeah, so if, yeah, so I just want to treat an empty string as null. So that's what this does. If it's null or it's blank, then return null, otherwise trim it, which means the method is slightly badly named because the method name doesn't really say that I'm going to trim it at the same time. And we can see how that works. You can see that on orange, it does the right thing. Banana, it trims it off. That one becomes null. And then if I've got a null pointer on that null string there, I can call force null if blank. It doesn't generate me a null pointer exception. It does still allows me to call that extension method. Okay, I'm just because I'm determined to do so, I'm going to run the test and it goes green. So extension method, that's good. Okay, number 8, let and apply. Okay, so these are two methods that are defined in the Kotlin standard library. And they use some of the two extension methods. So the first one up here is let. So it's a function. It's parameterized by T and R, which so the T means you can call it on anything. And R means it can return anything. And it seems really stupid, right? You pass it a block of that takes the type and returns a result, and it returns the result, right? So what's the point in that? Because it just returns the thing that you've just had. So what's the point in that is that T could be a nullable type. So if you ever look down here, what I've done in this code, rather than that nasty if null equals null null, what I'm doing here instead is I'm doing highlight question mark dot let. So remember the question mark dot means it returns the null if it's null, otherwise execute this method. So this is just, this dot let here is allowing me to filter through the nulls without, in a slightly more syntactic way. In fact, what I'd actually write here is, I don't know what yet. What I'd actually write is probably that. And then I'll do that, actually. I don't know why I've got that separate. There you go. So that's actually the code I'd probably end up writing. And it takes a bit of a while. What I love about let is it's a really simple method that's really, that looks like it's completely pointless, but it's actually really good at helping you to get rid of some of the gunk from your code. And let's do apply. Okay, so apply is kind of similar. It's another one-liner. Except this time, we'll look at the implementation of the method. It calls the block, but always returns this. And then it's this magic thing here, T dot open bracket, close bracket. So what that means is the thing I call it on, actually in the lambda, this points to the thing that I called it on, which I still don't get my head around in JavaScript. But here it kind of makes sense, and the compiler checks it for me. So what's that really useful for, right? So here I'm using the AWS Kinesis Producer library. That's got, so the Kinesis Producer, if we look at that, we look at the Kinesis producer. It expects me to pass in a Kinesis producer configuration. Kinesis producer configuration doesn't have a fluent a setup thing, so what you normally have to do is create a Kinesis producer configuration, call blah.set, metrics level blah.set, and then return the thing. What I can do is call apply. That's calling metrics level on the Kinesis producer configuration. And in actual fact, if you look at that, what that's actually doing is calling set metrics level. And this would be brilliant, except for the fact that I realized as I had this box up here that they have implemented a fluent thing, because that setter actually returns a Kinesis producer configuration, which is really weird. All the other Amazon libraries, the sets return void, and the withs are the fluent ones. So anyway, I still think that code's nicer, even though I could probably do it in a slightly easier way. So that returns this. So again, it's just a really simple way of setting up libraries, of using Java libraries in a more obvious way. Okay, number 9, operators. So my cow is nearly asleep now. Okay, so we've got that summary stats object. One of the things that's really useful to be able to do is to add those summary stats objects together. So what I'm doing here is implementing sorry, I've just realized I've completely ignored that side of the room. I'm sorry. Anyway, I don't like 2 screens because I don't know which one I should do. The camera's over here, so I won't move across. Sorry. Oh, I can. Okay, right. So over here, so what I'd normally do is actually put summary stats. I'd actually put this plus on the class itself, but I'm not going to do that because then I'd have to show the example higher up. So I've created an extension method on summary stats that you give it another summary stats, and what it does is create another object with all of the values added together. And then we can see what we've done down here is I just call combined equals a plus b down the bottom, and you can see social interactions is the addition of those two. What I love about this is I can control click that plus, and it takes me to the method that I've implemented there. So inside Kotlin, it's deliberately controlled the operators you can overload, and you have to explicitly say here in Kotlin, you have to explicitly say it's an infix operator that I want this to behave, and the word plus is the magic thing that says that's plus. And in fact, if I wanted to, I could do what it says there and just call that. But I think it's great to be able to create things that are the same, that behave in the same way as in the way that I've naturally expected them to do, and just get the operators like that to work. And let's have a look at how we might do that in a Java library. Okay, so here's the great news. So time left is duration standard minutes 2, so that's from Yoda. So my expected end time of this talk is now plus time left. Okay, so that's just straight Yoda. I haven't got any Kotlin wrappers around it. But you notice they've used the word plus for that, and actually quite often when you want to add things together, plus is the name of the method they use. And so Kotlin has taken account of that and said, well, it's Java, so they can't put the operator infix, but plus probably means they want to add it together. And so actually what I can do is just write that, and that works. And there's no wrapper around Yoda time to make that work. It just works because that's the convention that Java libraries follow. Again, what I love about this is I control click on that, and it takes me to the bit of the Yoda code that it's actually calling. And it's kind of one of my kind of golden rules on readability. I mentioned earlier that I love readability of code, and it's one of the things I value the highest. I kind of value actually working first, but secondly, I value readability. And I'm a simple man. My definition of readability, or my prerequisite for readability, is if I can't control click it in IntelliJ, that's not readable code. Right? I have to be able to control click on everything to see what you're doing in order for me to believe that your code is readable. Many people disagree with me on that, but it's my simple rule, and actually it works pretty well, I think. Okay, number 10. I say great IDE support and fast compilation. So yeah, the compiler's pretty fast. It's a bit slower than Java, but not massively slower. And as you've seen from some of the examples I've given here and some of the code that I've shown around here, actually the IDE support is brilliant, right? Funny enough. Who would have thought? that actually, if it's green in the IDE, it's pretty well going to compile. Occasionally, I've had that not be the case, but almost all the time, it's green in the IDE, it compiles. If it's not going to compile, it's red in the IDE. Now, for a Java developer, that's like, yeah, but yeah, of course. But if you've used other languages, that is not necessarily the experience that you encounter. Okay, so there's no example for that. Here's the summary. Okay, so for me, Kotlin addresses the verbosity of Java without introducing significant extra complexity. So one of the things I love about Kotlin is not so much all the stuff it's got in, but a lot of stuff it's decided to leave out. Whilst retaining fast compile times with great IDE support, encourages readability. So I've yet to find any Kotlin code that I've managed to write that I can't control-click on. So that's good. But it's also getting rid of the boilerplate and getting rid of the verbosity means it's easier for me to look at the code and understand the intent of what I'm trying to achieve. And it embraces the Java ecosystem. So two of those examples were around looking at how well it integrates with the existing Java libraries you use today. Right? One of the reasons I still program in Java is because of the quality, the variety and quality of Java libraries available in the ecosystem. And I can still use those. I don't have to wrap them. I don't have to try and make them look like how I want to make them. I can just call them. That's great. Yeah, so it's without trying to create its own sub-ecosystem. I'm supposed to ask you a question. And the first person to put the hand up wins the prize of... OK, you're disqualified. What's the answer? 42. Right. So my question is, what was, of the 10 things I love about Scala, what was number 7? I love about Kotlin. What was number 7? Sorry. Number 7. Extension methods. Was it? I hope you're right, because I'm now going to have to reveal the answer, because I can't remember. Well done.
I did write it down, though. So
That's still the right answer. It counts. It counts. So this project is on GitHub. So you can go and check out the original version of this project is on GitHub. So check it out and play with it, and wonder at the joys of IntelliJ's presentation mode, which is the first time I've used that, and I thought it was kind of okay. I'm at Tackers. You can tweet me, and you can talk to me afterwards if you want other stuff. And I don't know if you've got time for questions?
We have 1 minute for questions.
1 minute for questions, so yeah.
Over here.
Hi, I'm interested in how you've handled data classes in production.
Mm-hmm.
So specifically, data classes tend to be on one line. When I've been writing my own projects at home, I've gone down the route of actually trying to put all data classes together into one data.kt file, and then just allowing anything within a package to access and make use of those data classes. Mm-hmm. So I'm kind of interested in how you've approached that yourself.
Yeah, so the question is around how I manage, you had the mic, so I don't need to repeat it, how I manage data classes. It kind of depends. So I don't have them all in one place because I use data classes for different things, right? So, for example, the API has got a whole load of data classes that describe the JSON that I'm going to return from the API. So they're just sitting with the API. The things like the event data class that I showed you a kind of very abbreviated version of, that's in the event package. So I have them spread around the code is the short answer. And I rely on, when I change them, I rely on the compiler to tell me where I was actually using that. Not quite true, actually, because obviously when I'm serializing it to JSON, I need to make sure that I'm following sensible backwards compatibility rules, which I've got no compiler that's enforcing that on me. Does that answer your question, kind of? Yeah. I definitely don't do them on one line. Well, I only do them on one line if they're really short. So I'm a slave to IntelliJ, so the green line that tells me when I've gone beyond the margin, I'm too scared to cross that line. So it goes on multiple lines at that point.
Right.
Okay.
That's it. Okay. Thank you.